Hey, everybody. I'm just getting myself situated here a little bit. Gotta tighten that up a little bit, do a little bit of this, a little bit of that. Well, welcome, everybody. It is 2 hours UTC, which means it is time for another live stream of Astronomy Daily Live. Now, this is as the name implies, this is a daily live stream. It's just a casual, fun get together of friends who share a common passion. So, you know, turn off the TV, get away from the news. Let's think about astronomical things for an hour or so. Now, this is for new people who are just um, getting into astronomy. It's for the amateurs. It's for the pros. It's for everyone. Everyone is um, welcome here. Um, as long as we want to talk astronomy, it is open game. And at least eventually, I would like um, this circle of friends to gather around and talk about whatever you want to talk about for the next hour. Now, if there isn't anything, that comes up, then I've always got topics right back here in my back pocket. So not a problem at all. But this can be Q&A. We can talk about telescopes. We can talk about gear. We can talk about different kinds of um, instrumentation. We can talk about reducing data, um, collecting data. What do astronomers do? Uh, you know, daily, right? What's the routine? Um, we can talk about astro-art, both visual, audio, any other astro-art uh, that you'd like. We can talk about, specific papers, scientific or otherwise. If you've seen an interesting article in Sky and Telescope, or what is the European one? Hey there, Tom. Hope all is well with you. Everything's good here. Um, so yeah, if you see an interesting um, um, article and want to dive into it a little bit more, that's awesome. Uh, yeah, as I said, I've always got things to talk about when it comes to astronomy. So big shout out to to Slooh, Slooh. I've investigated it a little bit more today, and yeah, I think that's so awesome. It's a well, it's a community, of course, but it's sort of centered upon uh, these robotic observatories. Most of them are over uh, um, in the Canary Islands. I think there's five or six there, and then there's one down in Chile, and I think they've got. I think the biggest telescopes they have are like 20-inch. I haven't looked at all of the specs yet, but they have a solar telescope, and as I said, a number of scopes, all with CCDs on them. These are robotic, which presumably means that there's nobody actually there. And what you can do is you can subscribe, and um, depending on how much you pay, of course, you get certain benefits, and certain things can happen. And and uh, and so what you can do is you can you lost the stream. You lost the stream. How can we lose the stream? I don't know. I'm seeing a stream. Everything seems to be okay here. Let's see. I'm going to reload this. Sometimes this phone goes into weird modes. It looks like I've got a stream, Tom. So, yeah, okay. That's how it goes. These kinds of things I don't sweat at all, because this is just a fun, casual thing. So, you know, no pressure uh, at all. If if the stream falls out, oh well, we'll pick it up again tomorrow. So yeah, but glad you can be here. Just talking about Slooh, Slooh, and you can make a request to create what they call a mission. And the mission is just, you know pointing directions and exposure times, and probably a lot of other things. You set a bunch of parameters, and at the appointed time, the robot's telescope pops open and takes your pictures, and sends them down, and you can do what you want with them. And what I've noticed is that these are mainly being used for um, 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 astrophotos. So not really done, uh, you know, doing any kind of scientific work, but just snapping pictures. And I think that's great. I think that's an interesting model. Um, it's it's definitely a crowd that is pretty big. It's a pretty big crowd. You've got some pretty sizable scopes at some pretty dark locations, and uh, yeah, snapping cool pics of things. I think that's great. It gets lots of people excited, and many of them are going, to dive even deeper, and really um, get into the science. And yeah, if this kind of thing is inspiring, then I think it's great. I'm going to share my screen and go over here. I was going to do something else, but let's start at Slooh dot. I guess it is it com Slooh.com. I thought it was Slooh.net. I don't remember. Yeah, it looks like that's it. Loading the Slooh interface. Whoops, did I pop that back? No, I guess I didn't. Whoops. Let's try to share this screen again. Okay, sharing the screen. It looks like this is taking my computer resources. So maybe I'm not going to be on here very long, but there it is. Yeah, it's like completely frozen. Yeah, I'm watching the live stream over on my smartphone. Okay, it looks like it's back, but so they've got all these scopes, right? They've got Chile 1, Canary 1 through Canary 5. So they've got six telescopes. And let's see, can we? There's not much to show here until you actually log in. You can join for free. I forget what they call you at that point. Um, uh, let's see, but let's just run through some of these just to give you an idea of okay, it's loading the premium M44. This was taken with Canary B just March 18th. So it's so this was just taken like 4 hours ago. So it's pretty cool. I think this, this is going to get people excited at at least, and not everyone is at the same level. So you get things like this where I'm not exactly sure what parameters can be set. Um, so M30 is actually one of the Messier objects that is really, really hard to see this time of year. So that's probably why it's not the greatest shot of M30 we've ever seen. There's another one, the final shot of Messier 30. Uh, okay, very cool. Let's see what else there is just for fun. I'm not gonna linger on this too long. Uh, the Trifid Nebula and Mars. So yeah, this was taken almost a day ago or so from Canary 2. Very, very cool. Some more of the Trifid. Pretty good. I don't know if you can zoom in on these. Oh yeah, you can. Jeez. Very, very cool. Anyway, so yeah, just a really, really a neat site, an interesting concept, and yeah, for as little as like $5 a month, you can snap a couple of pictures a month, and it's cool. It's cool. You have access to all these tools and all that. It's really, really neat. Now, you know, my question is how um, um, what kind of science can be gotten, with these scopes? Because for me to see these scopes just as fancy cameras makes me a little sad. Makes me a little sad. It does bring a lot of joy. So that just completely wipes out sadness. Uh, but I would like to see. I would actually uh, um, want to see if I could do some science on these things uh, and see how well those do. I did do a search through the astronomical literature to see if Slooh data is being used anywhere, and I did not see much. The only thing that I saw um, were some observations of supernovae that that were done. Oh, I don't remember even when in the past few years. Now, Slooh, I believe, has been operational since like 2008, so it's been going for quite a while now. Maybe not as many scopes as they have now, but I think it's just awesome. I think it's great. And what I'm trying to do is go back to I thought that there was a like a description of each of the scopes here. Let's see. News. Um, maybe you have to Slooh Canary Islands. Let's just see. Yeah, see, it's gonna make me have to sign in and all that. I'm not gonna do that right now, at least. But yeah, so check this out. It's really, really awesome. They have a and I've watched a couple of their shows, and yeah, it's fantastic. It's absolutely fantastic. So neat stuff. Let's see. I've got my usual mug of hydrogen hydroxide tonight. It's HOH. It's still part of the new batch, and oh, it's awesome. So cheers. Yeah, very awesome. Very, very awesome. So let's see where we are here. Okay, very, very good. So what I thought I would do tonight, we haven't talked about asteroids in a while, so I thought that I would just sort of look around. And the first place that I like to go is the Minor Planet Center. So that's minorplanetcenter.net, and it will take you. It actually won't take you here. It'll take you here. So I like to look at these stats along this side. So showing the near Earth objects that have been discovered, the minor planets that have been discovered, comets, etc., 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 close approaches. Let's see. So let's see. We're just past mid month. So 62 new near Earth objects have been discovered in the past 18 days, 19 days. Uh, Almost 18,000 near Earth objects now are known. So these are objects that just have a very, very, very similar orbit to the Earth. Okay, so Tom has a iTelescope account. Cool. Yeah, yeah. Uh, I'm aware of um, um, iTelescope. Yeah, it's. I think these kinds of things are really, really awesome. I think they're um, useful in terms of you know if you don't have a scope and or if you don't have a dark sight and basically just want to do some looking or some photography. I think these are awesome. These are absolutely awesome. Don't know how good they are for science. So I would imagine that they're pretty good, but I don't see them being used for that. It's just a different crowd, you know. It's a different crowd, and but I like the model. It's an interesting one. All right, well, cool. So minor planets. So far this month, 367 of them, and look at that. There's over 3/4 of a million minor planets known now, and that is going up. Uh, I don't know if I call it exponentially, but there are hundreds that new ones that are being discovered every single month, thousands and thousands every year. Um, And this is just with the capabilities that we have now. When instruments like um, um, LSST come online, we're going to be seeing, thousands of these a day, new ones. So, hold hold on to your hats because these numbers right now are really really small, and this is 750,000 since we've been observing since telescopes were first used to find Ceres and Vesta. Ceres, I believe, is asteroid number one, and yeah, that was discovered way back, what, the 1600s or the 1700s or so. So we've only scratched the surface in terms of discovery. There are millions and millions and millions of them. At least that that's the guess. That's the guess. So of course this also keeps track of comets. So far this year, uh, 10 new comets have been discovered, and this is insane, right? This is totally insane, and this number is even very very small. Let's look at the actual let's see, summary of latest data. I think that's what I think that's where I was when we came into this. Yeah, okay. So check it out. 185,380,790 total observations. So we're we're getting close to 200 million observations. It's just insane, and it's just going to go up. It's just going to go up from there for sure. So these guys, they publish these circulars. I don't remember if it's every week, every other week. Trying to, I maybe it's every month. Don't remember exactly. But this is just, uh, I mean, if you like numbers, if you like looking at numbers, these circulars are for you. Let's take a look at the latest one from March 2nd. Minor planet circulars for minor planets and comets are published okay. Okay, on or near the date of each full moon. Okay, so basically monthly. So this is just information. This is just information. Most of this information you would use uh, if you were into calculating orbits. This is the kind of information that you want and need. But there's additional information too. So there are some new observatories that have come online in the past month, and so it presents that information here with an observatory code. Every observatory has a different code name. Um, so observations that have been deleted for one reason or another, don't know why. So these are objects that have changed identity. So as you can see, this object was originally 1993. Let me zoom in a little bit here. 1993 BS11. Now it's going to be called 1993 BB16. So and these are just observations that were made that have just changed designation. So look at all the ones that have just changed names in the past month. This goes on. As I said, if you like numbers, then these are your kinds of tables, because these are just the name changes so far. This is a huge document. It goes on and on and on. If you like asteroids, Minor Planet Center is the place to be. So, okay, so the following identifications with numbered minor planets. Okay, so they've now numbered some of the minor planets. So this was sort of its original designation, and this is the actual asteroid number now. So that goes on for a few pages. Then they get into observations of comets. And these are all the observers who have made some kind of a measurement of comets in the past month. These are the observatory codes and sort of, a description of the observatory. And then here are the observations of the comets. And basically, there's two things that are being measured. That is the position, the equatorial coordinates, the right ascension and declination at a particular time. So here's the date, and here's the time that was made, and here is the position that was measured. Now they can also measure brightness, magnitude. So some of these observations have that, but this is for for like here's comet 2010 S1. So here's just some new observations that were put in. So now you can see here's comet 2010 U3 Boattini, and on January 13th at a particular time on 2018, it was at this position and this magnitude, and it was observed by this observatory, whatever it is. Here's a different observatory making the same kind of thing. So this is um, called astrometry, and that's actually just measure of the stars, and this is just a location in the sky at that time. So these are all the observations that were made of this comet last month. It goes on and on and on for a while. Here's another comet, C 2011 KP36. And so here's just position and magnitude of that comet at that particular time. It just goes on and on and on. I mean, look at that. It's just insane, right? Like I said, if you like numbers, reading a minor planet circular is the place to be. But what this provides is orbit data. So you can take the positions here and use that to calculate your orbits. And I guess that's sort of where it's all at. Once you can calculate orbits, then you can make additional observations and see how the orbits change. And you can think about why and when and where and who. But this is just all the comets that have been observed this past month. Is this amazing or what? Yes, most of this is automated. This is done automatically. Data is collected, run through the ringer, measurements are made, and off you go. But as you can see, this just goes on and on and on. These are just observations of comets in this past month. You can see February 16th, 2018. There it is in the sky. There's a brightness observed by this observatory. It's all there, but I just think it's absolutely amazing and fabulous that all this information is available, and that it's being done. And yeah, I think it's very cool. See, there are uh, other things that this uh, circular does get into. Maybe we'll actually eventually get to them. I mean, just an enormous amount of data. And this is nothing. This is nothing compared to what we're going to be getting soon. Oh, okay. Observations of natural satellites. So these are these look like some of the moons of Jupiter, the date of the observation, and the positions again, and how bright they are. Now Jupiter 6, I don't remember which one that is. We'll have to find out. The easiest way I know to find out is to go to the Horizons website, the JPL Horizons website. Is it net? Remember, we're going to find out. Nope, Horizon Stewardship. Let's Google. Google. And we'll do it this way. Oh, it's going to JPL Horizons. There we go. Is that it? I guess that's it. I guess that is it. Yeah. Web interface. There we go. Okay. So all I wanted to do was come down here. Want to do some simple stuff. Well, okay, I chose the wrong one. I want to choose this one. Jupiter Jovian satellites display list. That's all I wanted to get was the name of number 6 and 7. So 6 is Himalaya. Is that the one we're looking at here? Well, yeah. So these are observations of the Jupiter moon Himalaya on certain dates at certain times. And number 7 is um, Ilaria or Ilara. I don't even know these things. Isn't that awful? So a couple observations of those. I lost it. Yeah, there it is. Okay. Anyway, so yeah, just a few observations of those. As you can see, they're very, very faint. You know, 16th magnitude, 17th magnitude, 18th magnitude. These are very, very, very small objects, probably most likely captured asteroids that, yeah, just went around. So then we get into sort of the main body of this. These are observations of the minor planets themselves, organized by observatory code. So it gives the observatory code, a little description, contact information, observers, what size telescope, and then the observations themselves are these little things here. And these, I think, are references to uh, to tables that follow. So this is just organized by observatory code, and some observatories make lots of observations, like this one, observatory 309. Oh, here's Space Watch up here. Okay, this one's on Peak, I believe. Um, and so yeah, I think these are just references to observations that are going to be taking that that are going to be shown later. But they're observing lots and lots of asteroids every single night. Catalina Sky survey in my neck of the woods. Lots of observations. All these observations are just there to make improvements to the orbits. Look at all the Catalina Sky survey observations. It goes page after page after page after page. It's insane. As I've said a couple of times, it's like, man, if you like numbers, this is the place for you. Still observation by observatory code. Maybe this is the main body of the circular. Glad they don't have to print these out, because if they did, whoo, we'd be going through trees. Any, we'd be going through forests on a daily basis. That's one of the things that these robotic telescopes like Slooh and iTelescope, you can use these for as if you want to make an observation of an asteroid, um, you can do that. And what they've shown uh, that can be done is you can take a series of images and then make a little movie out of them. So that's very, very cool. But it's just these insane lists of observations. Still looking. Okay, so is it? See, some of them just have couple a couple of them, and some of them have thousands and thousands. Just crazy. Just absolutely crazy. All right. Well, the reason why I was thinking about asteroids is that we haven't looked to see what asteroid occultations are going to be happening in anytime soon. So I'm going to direct your attention to asteroidoccultation.com, and this is just um, it's sort of a uh, calendar uh, of asteroid occultation events that are going to be taking place somewhere on the planet. Now there's a piece of software. It's called um, 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 Occult 4. That's OCCULT 4, that you can download and configure on your own um, machine that will um, um, give you um, occultation information for your location. So you can do this like on a monthly basis or so, and look and see what occultations are going to be taking place over the next month, and you can plan those kinds of things. Now, an asteroid occultation is nothing more than an asteroid passing in front of a star, and um, usually, usually the asteroid is too faint to actually see. But what you can usually see is the star itself, and so at the appointed time, and we'll get into this here in a minute. At the appointed time, you can, get yourself all set up, and you can be watching this star. And when the occultation occurs, the star will vanish, or at least get fainter as the asteroid, passes in front of it. And after a brief amount of time, could be a fraction of a second, could be several seconds. It sort of depends on the apparent size of the asteroid. And the apparent size of the asteroid has to do with two things, right? It has to do with the actual size of the asteroid, whether it's, 10 meters across, 10 kilometers across, 1,000 kilometers across. I don't think that there's any asteroid 1,000 kilometers across. And its distance away from us. So, the um, basically what you're seeing when that star blinks out is the shadow of the asteroid crossing your field of view. And so the actual size of that shadow is obviously going to be the the size of the asteroid itself. So if if you're looking at an asteroid, that's 10 kilometers across, then the shadow that it casts on the ground is going to be, of course, 10 kilometers across. Cheers. But depending on how far away it is, the apparent motion, the apparent velocity of the asteroid, of the shadow of the asteroid, is going to change, and so that's that's going to determine how long of an occultation you will actually see. So what asteroidoccultation.com does is it just sort of runs these predictions, and if there's any kind of occultation anywhere on the planet, then it gets listed here. And what they do is they sort of just give you a general, a general location as to uh, where this occultation is going to be visible. So as you can see, this one is visible in the USA. So this is the 14th of March. Oh, it's already passed. Let's look at the 19th of March and see what we've got for occultations today or over the next 24 hours. So there's one um, at 5:48 UTC going over, it looks like South America. It's let's see, I don't know how to read that. What is this time here? Duration. Okay, so this is just the the drop in magnitude of of the star. So this is the asteroid that it's actually. Yeah, okay, 946. Okay, cool. Thanks, Tom. um, so yeah, let's just dive into this. Let's do this one because it's passing over the United States. So we can click on this. This date here was the last time that this prediction was updated. So it was updated, what, a few weeks ago, which is probably good enough. Um, so this is what you come up with when you click on that little link. Sorry, it's probably hard to see exactly, but asteroid 814 Taurus, which is going to be magnitude 14.4. So, not visible with most sort of, moderately sized telescopes, is going to be occulting this star, TYC 2521 minus blah, 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 which is magnitude 9.2. So, magnitude 9.2 is pretty bright. So, you can definitely see that, in like an 8-inch um, um, telescope, and the star is going to be dimming 5.28 magnitudes. So it's essentially going to vanish, right? The occultation lasts for 8.1 seconds, and I don't remember what the A over here means. 81 degrees. I don't remember exactly. But then what they do is they make this really really cool map of where the occultation path is going to occur. So you can see here, this is time in minutes. So I don't remember, up here at the top, it says that it's starting at 7 hours 11 minutes UTC. So 7:11, 7:12, 7:13, 7:14, 15, 16, 17, 7:30, 7:31, way over here. So it looks like it's crossing the continental United States from about 7:15 UTC to about, just before 7:21. So it crosses the entire United States. The shadow of this asteroid crosses the entire United States in like 5 minutes. So that's really trucking, of course. It's really moving fast. And if you're in this path, you would be able to see it at the appointed time. So that's very, very cool. These maps aren't quite as good as another site, which maybe I should, let's see, is this going to do it? Okay, that's just a different, more of a detailed thing. Um, Detailed info. What does that do? Okay, that's just that. Okay. Let's see. Can we get into this? Yeah, that's getting into area that I'm not going to get into at all. What this also does is it gives you finder charts. So this is of course, the path of the asteroid, the shadow of the asteroid as it crosses the sphere of the Earth. But for us, for observers, what we want to know is, where is it in the sky? So here it is. Here's the constellation Leo down here. So this is Leo Minor. And as you can see, there's a little crosshair here. And that's showing where this event is actually going to occur, because the stars aren't moving, the asteroid is. So here's a box And that box corresponds to a 15-degree field of view. So narrower field of view. So zooming in, and then, whoop, actually went too far. 5-degree field of view. So narrowing in even more. This is just so you can figure out where to look, right? Because we got to be able to find this really faint star, this 9.4 magnitude star. So this just allows you to do that because you can star hop the stars. And finally, there's a 30 arc minute field of view, which is going to be close to a field of view of um, like a typical telescope. So there's our bright star. It's being covered by the crosshairs here, so it's kind of hard to see. But there's a nearby bright star here, just surrounded by a bunch of really, really, really faint stars. So, in a normal scope, you're probably going to see that one, and you're going to see that one, and you're going to see that one, and that's about it. So, what you'll do is you will uh, focus in on that star, and then you sit and you wait. And at the appointed time, that star is going to vanish, and it's going to vanish for quite a while, right? It's at like 8.2 seconds, 8.1 seconds. So that's quite a long time, right? It's going to be like, if it starts now, 2, 3, 4, 5, 6, 7, 8, boink. Yeah. So very, very cool. You can actually record these observations. There's a number of ways of doing that. Maybe I'll get into doing that at some point. And then you can actually send your observation in to, what is that place called? Um, what is this? Let's see, Asteroid Occultation. Occultations. Let's see. Let's see if I can find it. Oh, lost my Linux screen. This one. This one. So you can actually go in here and uh, worldwide occultation reports. Uh-oh. Lost my Linux machine here. Well, the screen at least. Get that back so my chat is up. Don't want to miss anything. Let's see. Go to main page. Is that it? Trying to get to the actual observations. Thought this was it. Talking about Taurus, just the one that we were talking about. That's going to be happening in just a few hours from now. Trying to find. Is this it? That's not what I was looking for. Where are the... I'm looking for the current observations that have come in, the reports that have just come in. Where are those? Bolt Watcher. Hmm. I want to say it's a lot like these, but yeah, see these? Okay, well, all right, didn't that say 2017? Right. Anyway, so here are some observations of some asteroid occultations that just occurred a few days ago. And let's see what Salia. Okay, so that's that. That's what that is. Let's see. I guess looks like it looks like trying to. Okay, so this is just yeah. This doesn't have the like the actual data. Um, Preliminary. What is this? See, but this is the kind of cool stuff that you can do depending on where where you're located and what your timing is. You can actually get asteroid shapes as well. So that's very very cool. See, so this person here timed the duration of the occultation and it was only this long. But this person up here timed the duration of the occultation and it was this long. And so depending on where they are in the path of the asteroid shadow, your timing is going to be different. And if you can get your timing, accurate enough, you can actually start seeing that, maybe there's a shape to these asteroids. And of course, that makes complete sense. These asteroids aren't going to be perfectly round. They're going to be, oddly shaped. And so, some observers didn't see any occultations at all. But if they happen to be in the path, then they start to see them. And, their timings are going to change and all that. Isn't that cool? So anybody can be a part of this. I think there's a sign up uh, um, thing that you have to do, but it's really really easy. It's totally free. You fill out the information, and that's it. So yeah, so far this year, these have been the occultation observations that have taken place. Quite a quite a few, quite a few. Let's see. Let's look at a few of these. Yeah, here we go. So these are just the shapes, based on the observations. So it's just a model. But there we go. Oh, look at this poor observer here. Just barely missed it. It looks like. So that's very very cool. So let's see. Let's go back and so that one's happening pretty soon in just a few hours. Let's see, it's 3 hours UTC now, so in 4 hours and 19 minutes, if you're anywhere on that path, you might go out and take a look. Now, I'm way down here in southeastern Arizona, so that's not gonna I'm not gonna see that one. But yeah, if you're anywhere on that path, check it out. There's another site that I definitely encourage you to go to, and that is this one. Where is it? Oh, now come on. I thought I saw it here. Didn't I see it here? Could have sworn I saw it here. Maybe I saw it down here. Here it is. Eric Bright's page. So this is just a different kind of a thing. Comet Holmes occultations. Why are we doing Comet Holmes occultations? I go home here. Here we go. So let's look at that same one from the 19th, one that everybody's excited about, 814 Taurus. So this has a Google map of the path. And I prefer this because you can zoom in with Google Maps and really, really narrow down your location. So, I mean, this is how, if you were really serious about observing this, okay, you could, let's see, it doesn't really matter where I zoom in because, you know, but so yeah, anywhere in between these two dark lines, you're probably going to have an occultation. So if you're in the city of Ellis, I don't know what state that's in. I've got to zoom out in order to see what state I'm dealing with here. Ellis, Idaho. So if you're in Ellis, Idaho, you are definitely going to be seeing this occultation. It's going to be taking place, yeah, somewhere around like 7:20 UTC, something like that. Let's go back to the list, to this one, that one, to this one. And let's see what else is going on. There's a Western United States one occurring at 12:31 UTC. Okay, but yeah, that's going to be happening really, really close to sunrise. You can sort of see here's the terminator. So this is the night, or the day side. This is the night side. So yeah, that's going to be happening really early tomorrow morning. So no real chance of that one from my location. But yeah, I sort of go back and forth between this one and this one. Pointsource.com, POYNT source.com. And between those two, you will be set. You will be definitely set. You can see when these are occurring, which asteroid it is, which star it's going to be passing in front of, and where on the planet that's going to be taking place. So here's a okay, this is the time, right? Yeah, maximum duration. So that's how many seconds the occultation is going to be taking place. Look at this, 26.7 seconds for a 9.2 magnitude star. So that's going to be a nice pass. Oh, not going anywhere near the United States, not going near anywhere near land as far as that goes. All right, well, cool. I think I am going to get out of here for now. It's been just over an hour. It's been awesome. Appreciate you folks coming in, spending some time talking astronomy, pretty much talking about anything astronomical. But yeah, I think it's time for me to exit these waters, get back to getting some getting some late dinner in me, feeling hungry for sure. So cheers. And we will do this again tomorrow night for another Astronomy Daily live stream coming at you every single day at 2 hours UTC. All right, I'm going to get out of here. Yep, the ship is calling, so I'm going to get back up to it. I've got some updates on my project to characterize this telescope, turn it into a scientific instrument. It's looking pretty interesting, but I will try to give an update on that tomorrow night. As my time is up, I definitely respect your time. Don't want to keep you here any longer than planned. Sometimes we go over a little bit, but I try not to do that. So, yeah, having fun doing astronomy, thinking astronomy uh, is always very, very awesome. So, I'm glad you could come in either live or later on. Check it out. Make sure to subscribe. Um, if you haven't shared, make sure to share this video around too. I'm definitely interested in growing a nice little crowd. We can have some good conversations that way. All right, I'm going to get out of here for now. Peace out. I will see you again on the spin. All right, cheers, everybody. Take care. Have a great day. Have a great evening. And yeah, I will see you again tomorrow. Happy astronomy.